Welcome back to Spring Into Math 8. Today is the last video you can watch for the entire school year, and we're going to review all we've learned in our statistical unit, which is Chapter 17. Scatter plots was the very first topic we talked about, so let's go ahead and review that topic together. You should know that scatter plots are a graph that shows a relationship between two sets of data. The two sets of data are graphed as ordered pairs in a coordinate plane or as a graph. There are different types of relationships that can come out of graphing information. The first type of trend we could see when graphing some statistical information is what we call a positive linear relationship. This means as the x value increases, the y value increases. Basically, if you're running a solid business, you're going to show that you have a profitable margin on your products. A negative linear relationship is pretty much the opposite of a positive one. It has a downward trend on a graph, or a downward slope. As x increases, unfortunately, the y value is decreasing, and that's what causes the graph to give a downward look. We can also have what's called a nonlinear relationship. This means that the points lie in a curve or some other shape than a straight line. So in this case, our points are looking like a nice curve, or a bell curve. The last type of relationship we can have from statistical information being graphed is what we call a no relationship. This is when the dots on the graph or data points are all over the place and they really don't have a general trend. We call this a no relationship. And the example here is a comparison between colors in the rainbow and the sizes of people's shoes. Those two items really have zero correlation, and that's why we can say that this graph looks like and shows a no relationship. Now, let's talk about the best fit line. This is the second topic we talked about, and we use a best fit line to help us understand statistical information as it's graphed in a much better way. So a line of fit, a line drawn on a scatter plot close to most of the data points. In reality, we want about half of our data points above the line and about half of our data points below the line. If we can get half above and half below and draw a nice line, that's when we have what we call the best fit line. Now remember, the best fit line is going to look different for every type of scatter plot you look at. So here's a picture of what we have, a nice best fit line. When looking at a relationship to determine if one exists between specific items, we have a graph of data. So now we need to know if a relationship does exist, and we use a best fit line to show if it's rising or falling, positive trend or a negative trend. A rising line would indicate a positive relationship, and of course a falling or downward sloping line would show us a negative trend. This graph in particular shows the price of items and the number of items sold. So this graph indicates a steadily rising best fit line. This should indicate, and we should know, that this positive relationship is shown between the price of items and the number of items sold. So we have a nice example of a positive relationship in terms of a scatter plot, as well as a nice best fit line. We've got about 3 points above the line and about 3 points below the line. And in fact, in this case, we actually have one data set coordinate that's falling precisely on the line. And that's okay. To review a best fit line, we need to make sure first of all, you have to plot points on a graph. And if we can't plot points in a graph, we can't draw ourselves a best fit line. And again, you should try to get half those dots above the best fit line and half the dots below the best fit line. Data of linear equations. So we need to review again how we go ahead and graph a linear function or linear equation. The example here is y equals 2x. We can pick apart this function and graph it on a graph. So x, when x stands alone, we know that it has a value of 1 whole. So we can say that with confidence the slope of this line is going to be 1, or up 1 over 1, up 1 over 1. Now this plus 2 on our end of our function here that they gave us indicates where to start our graph, which is the y-intercept of positive 2. So we have our coordinate plane here, and you can go ahead and plot your points on your line. Don't forget, start at positive 2 on the y-axis, because that's where it indicates we should start. We've plotted our line here. Our first dot we dropped was at 0, 2, because that's exactly where the function told us to start. And then we went up 1 over 1, up 1 over 1, and dropped our coordinates there, and went ahead and connected them, and we have our nice function graph here. Our last topic we discussed in this chapter was data tables. We have some vocabulary here that we can discuss. A two-way table displays two categories of data collected from the same source. A joint frequency, which is every entry on our data table, and our marginal frequency, the sums of the rows and columns on our two-way table. So here's an example of what we can look at. Again, we're reflecting here on two different areas of a town or two different areas of a state. We're looking at people who pay income tax and people who don't pay income tax. And we're going to answer some questions based on the information they provide for us in this data table, or a two-way table as it shows. Question A, what percent of residents pay Area A income tax? So we have two different pieces we can pull from our data table. We know that there are a total of 45 people surveyed here. Some of them pay income tax and some of them don't, based on the survey we got. So the number of people paying taxes was 30. So 30 is going to be our numerator on our fraction. And 45, the total number of people who were surveyed, goes on as the denominator of our fraction. We need to go ahead and divide our fraction and then multiply by 100 in order for us to find a specific percentage for our question being asked. Now 30 divided by 45 times 100 here gives us 66.67%. Basically, 2/3 of people of this area of a specific town or state are paying their income tax. Now the people who aren't paying income tax are going to have a difficult time when tax season comes around, as they're going to be fined for not paying their taxes. Question B asks us a little bit of a different type of question. It says, find the percent of Area B that do not pay taxes. Earlier we're looking to see who did pay taxes, and now we're looking to say who did not pay taxes. So we need to take the information out of the data table we're provided. That information being that we have a total of 55 different people we surveyed when we went out and asked people who was paying and who was not paying our taxes. Now, 55 was gotten from 15 plus 45. 40 people are not paying their taxes according to the survey, and 15 people are. So 40 is going to go ahead and be our numerator on our fraction, and the total number of people surveyed is going to be on the bottom of our fraction. We're going to divide these two and again multiply by 100 to find our percentage to answer our question of who is not paying taxes in the specific area. When we divide and multiply, we find that 72% of people are not paying their income tax in this specific area. It's been a lot of fun to work with you this year. I hope that you learned a lot from me, and I hope that you have a great time in high school next year. Signing off here, Mr. Burns.